Aaron O'Brien, and I'm going to go over the process to get you through lesson 1. So if you're using Flow 2D and QGIS, you should have on your computer C drive users, public documents, Flow 2D Pro documentation. Before you start the class or before you start the training, you want to pop this into your quick access so that you can get to it quickly without having to navigate to different locations. Once you're in here, the first thing to do is to open the workshop lessons document right here. It should be workshop lessons dated around May 1st, 2021, because that has corrected and fixed images and all of the new processes that go along with the Flow 2D plugin. We'll be working with example projects. Typically, there are a lot of different example projects in this folder, but I combined them all into miscellaneous except for QGIS tutorials. So if you don't see this folder, you might need to install the latest version of the QGIS documentation installer, and you can find that on the website, on the QGIS page of my website. We're going to start by opening QGIS 3.18. So this should work with 3.14 through 3.18 or even higher at this point. I'm just going to go ahead and open one, and I don't need this anymore. I can close that down. And while that's loading, I'll go ahead and go into lesson 1, and we'll be working mostly out of lesson 1 as far as our QGIS two QGIS files go. The QGZ and the GPKG, they'll stay in lesson 1, but the rest of the data will be using all of the data and exporting to the other lessons, which you'll see as the videos progress. So we'll be doing one video per lesson. Lesson 1 has parts 1, 2, and 3. And the way to set it up is to just start by grabbing the project domain from the lesson folder. I just leave this open. You can minimize it or move it to the other page, whatever you want to do. And I'll also be using the procedures in the workshop lessons. This starts us out with lesson 1. As you can see, for lesson 1, we'll be using the elevation data, the project domain, the Manning's data, and some inflow. Actually, we won't use that inflow until lesson 1, part 2. So lesson 1, part 1, getting started. We'll go to the step-by-step procedure. Open QGIS, import the project domain. We've just done that. Set up this project, create a grid, save the project, assign the elevation to the grid, assign the Mannings, assign the control variables, save the project, export the Flow 2D, and run the model. That's the steps we'll be taking. So I'm going to just move that out of the way. And you saw we already imported the project domain, and that also set our project coordinate system up. If you were to look at some options here, you have the coordinate system for your project is coming from the first layer, and you should also choose this radio button here. So any other data that you're loading is going to just default to the project coordinate system. That works really good for Flow 2D projects because the geo packages, for whatever reason, when they try to bring the data in, it doesn't recognize right away that those layers are all part of the project coordinate system. The next step is to set up the project with the settings tool for Flow 2D. So if you click the settings tool, you can create, don't bother with this button. I'm not quite sure how to use it, but this one here, create the project. That should take you straight to lesson, let me get that out of there. That's better, lesson 1. And then I'm going to build a geo package. I'm just going to call it lesson 1 just because that's easy. And save it. And now what it's doing is it's building the geo package files, and now it's going to assign the coordinate system to the project. The coordinate system we'll be using has an EPSG code of 2223. So you might not see it right here because you might not have used that before, but you should see it down here. So be sure and drag this bar to the top until you find it, click it, and click OK. Alrighty, now you can see that I have the correct coordinate system and the correct units. If you want at this point, you can change this to 30 And you can change this to some whatever the lowest Manning's N value you might use on your project, or maybe the most common Manning's N value. It really doesn't matter. But the default is 0.04. And now the model is ready to go. So the first thing we will do is create the grid. I'm going to hit the Create Grid button over here in the Grid Tools. Oh, by the way, when you open your Grid Tools, you're probably going to see a bunch of these opened. So just go ahead and collapse them all, and then you can click on the grid. I have an external layer. This is an external layer, and these are the GeoPackage layers. And it's a project domain, so I just hit the PR buttons, and that took me right to project domain. The cell field is cell size. So if you can add that field to any shapefile that you have to use this to set up your grid. I'm gonna click OK, and that will build the grid. It'll also copy that polygon to this layer computational domain. The grid is complete. I don't need this layer anymore. I can either move it to the bottom or I can remove it. In this case, I'll just remove it because I'm completely done with it. Alrighty, now that gets us back to the manual. So we have, let's go down here to step 1. We open QGIS, we imported the project domain, we set up the project, and we created the grid. The next thing to do is to save the project and then do the elevation. So saving the project is very simple. You have the project save button here. So you have a project save button, a layer save button, and on some of these you will have, let me grab one that has one, a widget save button. You'll know the difference of all of those as the class progresses. So I'm going to save the project. Again, we're going to call it lesson 1, and I don't need to say anything else about that. Just set that up, and then I want to show you what we just did. So now we have a lesson 1 QGZ that stores the style of the layers, the alignment of the layers, and the coordinate systems of the layers. The GPKG, the geo package, stores all the georeference data and tables that make up the layers. It's just a database. All right, back over here, the book tells us to load the elevation TIFF. So that's very simple. Back in lesson 1, I have an elevation TIFF file. And by the way, if you can't see your extensions, this could become a little bit harder for you. So if you can't see your extensions, click the View menu and then just check File Name Extensions. I know that's very common for people not to see their extensions. I'm going to grab the elevation TIFF and drag it here. And as you can see, it comes in a location that covers everything. So if I want to move it to the bottom, the best way to do that is to click on it and drag it until you'll see the icon looks like the little Ghostbusters sign. And then if you move it slightly, it becomes a little arrow, Ghostbuster sign, arrow, right underneath my cursor is where I'm looking. And then if I drop it, it just goes down to the bottom. Sorry, let me try that again. Yeah, and now it's on the very bottom of the map. The next step is to assign the elevation. I'm going to use this button right here. This creates a raster warp. There's only one raster in here right now, so that makes it very easy. -9999 and multi-thread and average of all no data pixels. I don't actually have any no data pixels in this one, so I do not need to fill no data. And it's going to use the raw input resolution only. So this is 1 foot by 1 foot raster, the base raster. It is now going to warp that into a 30 foot by 30 foot and align it to the grid and then sample from the centroid of every cell onto that. Once the sampling is finished, you can even see the completed interpolation file because it comes right here. So I'm going to come down here for a second and select this guy. And then I'm going to take the one that we just created through the warp and pull it on here. So as you can see, it's the exact same size of my original, of my grid, except of course all rasters are rectangles or squares. So it has a little bit of extra data down here. So if you turn the other one off, you can see how they differ. Bottom line is, what this does is it takes the elevation from this layer and it does a weighted average of all the pixels that are aligned, that are, I guess, inside or connect or touching the grid. It does a weighted average of any of those pixels and assigns a single elevation for the 30-foot by 30-foot grid. Oh, we don't need these anymore, but I'm going to go ahead. I'm going to remove this one because I won't need it until I need it. So there's no sense in clogging up the layers. And then this one I will leave here because I use it pretty regularly. So I have no problem leaving it on there. Now that is complete. Let's see what the next step in the book says to do. Assign the grid elevation, assign the Manning's elevation. Okay, we can assign the Manning's in the almost same manner. We grab the Manning's shapefile and pop it into the map. And again, we don't really need it on top, so we can move it to the bottom. And again, you see that, just drag it right to the bottom by dragging it slightly to the left and dropping it. Here's your Manning's calculator here. I want to use all grids. I want to update all grids. And again, M will take you to the map. Enter will load the data. In this case, this shapefile only has one field, and that is N value. You can do an area average if you're working on a district project. You can do an area average, but if you're working on just a standard project and you're not required to do a district, an area weighted average, I recommend the point sample because it is much faster and it's its accuracy is fine. Click OK and just let that finish. While we're waiting for it, we'll come back to the book and see what our next step is. Okay, just to show the grid. Okay, so the Manning's roughness is finished. We no longer need to see the Manning's data. So you can either remove it or leave it in there. Typically, I just remove it because it's kind of a huge shapefile and I don't need it. Okay, schematic layers. Now we have done two things to our grid. Aside from creating it, we have filled two tables in our grid. So if I open the attribute table, I've got to grab it. It's on the wrong side. You will see here that we have N value and elevation. So you have all kinds of controls in here. You can do sorting just by clicking on the layers, or you can do math with this table. You can do a field calculator. You can do all kinds of things with these tables, including zooming to these areas and whatever you might need. But so far, we only need the N value and the elevation to set up the project. Oh, of course, then the grid element FID is our grid element number. So if you needed to know quickly how many cells you had, you could come down here and you'd see that you'd get 54,307. We don't need this anymore, so I'll go ahead and close it. Just to warn you, if you have a really big project and you try to load this data, it could take up to 2 minutes to fill that table on a really big project. So be careful about using that. But the great news is if you open it with a filter, it loads super fast. If you filter out like just the cells that you're interested in. Back here, let's see, that was okay. That was pretty much all we needed to do, is just to see the data. Sorry about that. Get you on the right page here. And we wanted to see the data. And now we are going to assign the control parameters for the map. And one final thing is, let's see, sorry. That might be better if I can do it that way. Yeah, that's much better. Okay, so we'll be setting up these control parameters in the red blocks. We can ignore anything outside the red blocks, and then we'll do the numerical stability parameters on the second tab, and then we don't need to do anything with this tab. Okay, so let's go here to the control parameters. I want to use a 24-hour simulation time for this particular model, and I want to 0.1 every 10th of an hour will get some output data, and 0.1 is also good. Oh, actually, I we're not going to use detailed graphics yet because it won't work because we don't have anything to plot because there's no water yet. So it doesn't really matter what you put here. It'll just kind of default back to text screen at this point. So I can just leave that blank. But over here, I can put in 0.9 as my limiting fluid number. The shallow N looks like it's going to default to 0.2. The depressed depth has a 3.0. We'll see why in a few minutes. And the numeric, or actually on the review day, and the numerical stability is set up defaulting to 0.04, but that's kind of a low number. If you're not using the flood control district's methods, this should not be 0.004. You can just 0.01 is fine. And so what's going to happen with this surface detention is that the cell will fill up to that depth before it starts to share with its neighbors. So it'll be 0.01 feet before it starts to share with any of its neighbors. And if you're working on a flood control, Maricopa County flood control project, then you need to be using 0.0042. And that is complete. Oh, wait. Yeah, I did. I got the numerical stability. Okay, we're good. So you just click save and you close that and then save the project and then export the project and then run a simulation. That's the next 3 things to do. So save the project and then we export the project. Right now, just ignore this. There's nothing to export for rain yet, but we will be exporting everything that we just created. So I'm going to click OK. And as you see here, I already have an export folder set up for every lesson. So please use mine. That made it a lot easier to help you if you get stuck. Tells you where it exported and which of the files it exported. Also show you that over here in the lesson folder. If you see here, we have these 4 files. Oh, and let me just go ahead and open those. All right, we'll start here. This is the control data. And as you can see, not much going on here yet because this project is very early. Topo.data is X coordinate, Y coordinate, elevation of every centroid of every cell, starting from 1 to n number of cells. Taller.dat, you can see we changed that to 0.01. These variables will be explained in another lesson, so stand by for those. Manning's N, so you have a grid element number and the Manning's value for that specific cell. I'll go ahead and close these out because we don't need them right now. And I can just close this too. Okay, now we do a run just to make sure that the model will run. So I'm going to click OK, and I'm going to let it start. Right now it's building, doing its tests and building all of its data. And now it's starting its run, but obviously there's nothing in there, so I'm just going to click exit because we don't need anything. Now the first thing I check, and first and only thing I check right now in the summary.out is just to make sure that my grid cell size is calculated correctly. See, my grid element size right here says 30 feet. And it also tells me how many cells I have and some information about the area of my grid system. So that's the summary.out. And I always check that on a project because sometimes if you don't set up your computational domain correctly, your cell size is wrong. So keep that in mind. And that is pretty much it for lesson 1, part 1. So I'm going to save this and then we will go straight into lesson 1, part 2, where we will learn how to set up a recovery file. Okay, so it's very simple. We just need the QGZ and the GPKG. We don't actually need this .dat files, so that this is not correct. Just those 2 files. And overview, required data, step-by-step instructions. Okay, so we will create a recovery file, and then we'll show you how to recover a project. So step 1 will be to close QGIS and then zip these 2 files together. And then we will delete these 2 files and unzip what we just compressed and then open it. Okay, that's very simple. Okay, so let's go ahead and close QGIS. So now let me show you what's going to happen here. As soon as I close QGIS, these two files are going to go away. These are just tracking your changes. And once we close it, the changes will be applied and everything will be closed. So let's go ahead and do that. And then I'll zip this. I use 7Z. If you don't have 7Z, you can use this, or you can use WinZip or whatever you have. But I like 7Z because it makes a GeoPackages really small. Okay, so here is the GeoPackage that it, or sorry, the zipped file that it created. And as you can see, it has excellent compression. I'm also going to rename this. So let me just to something that is, just let you know where you are in this project. So let's say elevation and Manning's. Okay, now I know what's in there. Now, if I went back into QGIS and I was doing some editing and I just completely messed something up and I could not undo it just because GIS is not very good at undo, I can always go back to this point and start over. It doesn't happen to me very often anymore, but when I first started out, this was a bit of a saving grace. So I deleted the other two files, and now I'm going to extract these. So if I right click that and I did it with 7Z, I'm just going to use extract here. If you have your zipped file and you want to restore it with Windows extraction, you'll right click it and it'll have somewhere in here extract, and then just make sure you're extracting it back into lesson 1. So if you don't, just cut and paste it into lesson 1. Okay, so I'll grab that right now and extract here. And you'll see right away that my lesson 1 comes right here. Now, if you have a lot of versions on your machine, you might click that QGZ file and it might open in a different version. So just be aware that you're opening it in the correct version. It's asked me if I load the model. So this, I don't know, I'm sorry, I went a little fast on that. In order to get back into your project, you get there from the QGZ file. You load that back into QGIS. You don't load the GeoPackage. So I'll just click yes, and now this is going to load the GeoPackage. And it loads it right back up and gets your QGIS set up the exact way you left it. So that is lesson 1, part 2, recovery. So at the end of every lesson, I want you to build a recovery point by closing out QGIS and zipping those two files together. You don't have to extract them and do that part of it, just zip them together. Okay, let's see here. What do we got? Lesson 1, part 3. Okay, here we go. Hydrology, rainfall, infiltration. So we're going to set up some rainfall runoff model. So what I have is a rainfall distribution curve, SCS 24-hour type 2, a NOAA Atlas 14 raster, and a land use and soil shape file. And I think I also have a file from lesson 1 that we'll be using here. Okay, step by steps, what we'll be doing. Opening the QGIS, loading lesson 1, just did it. Importing the aerials, assign the inflow, assign the rainfall, assign the infiltration, turn on the control variables, save the project, export the data, and run the model. All right, that's pretty simple steps. We are down to step 3, loading aerials. So I use this guy right here to load my aerials. And if you don't see all these maps, this is called Quick Map Services. It's a plugin that you can install. If you don't see all this data, you can come down here to settings and there'll be an opportunity to add more options and get the contributed pack. I've already showed that in another video, so I'm not going to go over it right now. Let's see. I like using the Google satellite because it doesn't have labels. Okay, so this is my project area and an aerial for it. I don't really need it right now just yet. Well, actually, I guess I will. I'll need it just now because we're going to add an inflow and we want to see where we're going to add it. So we need to zoom in on this park on the upper right-hand corner, and then we'll add a boundary point to the inlet of this hydraulic structure or of this culvert right here. And this we're going to just work through these steps. Okay, so move this over here, and you can either use your mouse wheel or your zoom tools, and we are just going to zoom in enough to where we can see where we want to put this inflow node. I don't need all of these. Again, I just need boundary conditions. So I'll collapse them all, and then boundary condition. I want to apply a point inflow, an inflow point, and that will be right here. It is an inflow, and I don't need to change anything. I click OK, and then I click Save, and then I click OK again, and then I can rename this. The name of the basin is Grover, so I'm going to call this Grover in 1. There could be more than one inflow point into a basin, so I'll just say Grover in 1. It is a floodplain inflow node. It has an inflow hydrograph, and this is the name of the hydrograph. So I'm going to call this Grover in 1 24-hour 100-year. Click OK. And now the time series is named, but the time series data is still empty. So the next step is to open the time series data from lesson 1 in text or notepad. And then this is a very simple process. These windows get huge. I will Control A will select everything. That's important because you need that final carriage return that's invisible. You need that. Control C will copy everything, and Control W will close the window. Move this back out of the way. I'm going to put my first cursor down here in the table editor, and I'm going to click paste. If you moved these or you can't see them or whatever, you might have moved them, you might have closed them, you might have turned them off. You can get back to them with the view menu and by going to panels, and then you see all here down here are all your Flow 2D panels. Okay, and as you see, it automatically loaded the data into the table for me with the paste mechanism, and it plotted the data in the window. That's all I need to do for now. Let's go back to the document and see if that was it. Let's see. Okay, inflow.dat, open with Notepad. That window's on the wrong page. That's unfortunate. We'll figure it out. Paste. Assign the rainfall. Okay, so we are back. Oh, let's just make sure we do this right. Okay, grab the NOAA Atlas 14 raster. Set up the rainfall data. Import the rainfall curve, distribution curve, and perform the calculations. There's a couple calculations that need to be performed. Okay. Yep, easy peasy. Okay, let's go ahead and do that now. So we're done with the boundary condition editor for now. Actually, we're not. We could do this right now. I'm going to go ahead and hit the schematize button. I forgot to do that. And now that converted the data that was in here into Flow 2D data, applied it to the grid. So that's what the schematize buttons are going to do from here on out. Now we go to the rain editor. Yes, we do want to simulate the rainfall, and this project calls for 3.74 inches of rainfall. I am going to apply the rain on building switch, even though we don't have buildings yet. That way we don't forget to do it later. My rainfall distribution, I will open this from a file. So if click open right here on this guy, and it will take you to one of two places. You can either get your data straight out of lesson 1, or you can get your data out of the rainfall distributions that are installed with Flow 2D. I'm going to go ahead and select the one I want and click open. And if you don't have one that you want in the rainfall distributions, you can make one and put them in here. It's very easy to do this. As you can see, this is just space delimited data with just time and percent rainfall, but the percentage is not 1 to 100, it's 0 to, or sorry, the percentage is not 0 to 100, it's 0 to 1. I'm going to go back to my lesson 1 just so I don't lose it. Okay, we opened that rainfall data and it's done. That is complete. Now I want to, oh, I missed a step. Sorry about that. Back in lesson 1 in the hydrology folder, there is this raster. I'm going to drag it to the map, And you can see that it will cover everything because, of course, it went just over the layer that I was last working on. I'm going to zoom out to this so you can see what it is. Zoom to layer. So pretty much it's very simple. This is your Arizona rainfall for the 24-hour, 100-year in inches for the state of Arizona. You can get this from Maricopa County. They make these maps and they can make them available to you if you contact them. So you can contact your flood control district to get these. I'm going to turn that off. I don't need that. Okay, and I also don't need this in my way anymore. So I will pop that down to the bottom, and now it's under my picture, and zoom back in to the computational domain by clicking the computational domain, right-click, zoom to layer. And that'll bring you right back where you need to be. Okay, so I want to apply a depth area reduction to the map or to the grid. So I will click this, and then I will use this button to calculate the depth area reduction. My source raster will be the NOAA Atlas. My no data value, that this has nothing to do with the map I'm reading from. This is just going to apply to the interpolated map. Use multi-thread. In this case, you can probably do the maximum value for the non-data pixels. It's not really going to matter because those pixels are like 2,000 feet by 2,000 feet by 2,000 feet. So they're so much bigger than our version that it won't matter whether or not you use an average or a max. And it starts the processing and it tells you that it is complete. And the next step in the book takes us, so the rainfall is actually done right now. It's set up and ready to go. Just needs to be exported. So now we're going to move on to the infiltration data. So now Flood Control District of Maricopa County uses green amped infiltration. Pima County uses SCS infiltration. I don't know what Mojave County uses, but I think they might also use green amped. And then every other county uses some kind of version of whatever. They might use some kind of version of either of those. So if you're doing a Maricopa County project, you're going to have some extensive good data to use. And this is the process you'll use for them. I will do another video on any other processes. Okay, so this is very simple. We'll take the land use shapefile and the soil shapefile and drag them to the map. And then we'll open the infiltration editor widget. So back over here, I have a land use and a soil shapefile. And I'm over here on, this is my active layer. So when I pull those on, they're going to be stacked right on top of that layer. So again, I don't really need them. I'll just drop them to the bottom. I don't really need the picture anymore either. And I don't need that anymore. Actually, I don't need this at all. So I'm going to remove it. Don't need that anymore. And then you can see that these are there. Okay, so back over here, collapse all your layers, open the infiltration editor. Global infiltration, this button right here will set up your global values. That'll be anything that is not covered by a shapefile or a polygon will just default to global. Depending on what version of the plugin you're using, you might need to reset this to 0. It had a default of 1 in there for a while, and that's not right. And then you can just click OK, and that will open up a calculator for green amped. Okay, if you're in Pima County, you're going to use global SCS instead, and then when you click OK, that'll open up a calculator for green amped. And if you're in Denver, you're going to click Horton, and click OK, and that'll open up your calculator for Horton. But we are using green amped. So now I use calculate the green amp button. So if you get your project data from Maricopa County, all this, they're going to provide all of this to you in their land use and soil shapefiles. So all you have to do is set up the fields. Okay, so your soil field is XKSAT, rock outcrop, the effective impervious area, and a soil depth. This is your hydraulic conductivity. This is imperviousness due to rock outcrop, imperviousness due to whatever, I don't even know what properties are part of this. Soil depth is a calculation to help minimize the infiltration in steep mountainous areas. Land use layer. So the land use layer will be initial saturation, which is wet, dry, or normal. Maricopa County doesn't use vegetative cover, so if you use vegetative cover, you'll have to have an extra field. Initial abstraction and the impervious areas related to buildings and parking lots and maybe, I don't know, anything else that has an area that's impervious because of concrete or whatever. Then you just click OK and the calculation starts. I'm going to pause the video while that completes because it takes a bit of time. Okay, we're back because the calculation has completed, and if we click OK, now I'll explain to you kind of simply what this did. It took and it intersected both of these shapefiles to the grid, and then it computed an area calculation, and it gave a weighted average of all of the polygons within each grid to assign those variables. And the variables that you get are a little bit different than the variables that are in the shapefiles, and I'll show you those in a minute when we get to the export portion. Let's see, so we no longer need these shapefiles, and we now have infiltration layers with green amped data. And that is the end of lesson 1, part 3. So we need to just do to make sure that we have set up our control variables correctly. We can now put this back to detailed graphics and check our processor switches, and then just make sure that nothing in that window changed. Okay, so this can now be put to detailed graphics. Before it wouldn't have worked, but now there's some water on the grid. Got my limiting fluid, got my shallow N, got the rainfall, got the infiltration. I did have to check that one. That's important. Click Save. Don't need to do anything else on the other tabs because we didn't change anything there. Okay, now I'm going to right-click this and open the attribute table so that you can see what we calculated for that. So hydraulic conductivity, soil suction, d theta, soil depth, initial abstraction, and the RTIMP value for the imperviousness of the buildings and whatnot. So this is complete. We're ready to export. We'll use the Export Flow 2D button, and we now have rain and infiltration, inflow elements, and mannings. Notice I didn't do a downstream boundary condition yet. That's going to come later. I want you to see a full complete run before we do that. I'm going to click OK and choose that file, select it, and it tells you which ones it exported. Click OK again, and you can see that what we got was the new stuff that we got was, let's see, we now have this many data files. So Flow2D made this one, the FlowPro engine made this one, cadpoints.dat, and the FlowPro engine made fplane.dat. It just makes it while it sets up some tables. The neighbors, it also made the neighbors.dat. It does that so it can calculate and make sure that your grid element neighbors are correct. Let's see, so we added this one, and this one. I'll go ahead and show you those in Notepad. All right, Inflow is very simple. This is the cell that plots when we run in detailed graphics, and this is the cell that we assigned. You can have as many cells as you need. We only had one in this one just because it's simpler. Time in hours and rainfall in cubic feet per second, or if you have a metric model, cubic meters per second. Rain.dat. Make sure that the building switch is on if you're going to use buildings. We're going to use them in the future. It won't hurt anything for now. 3.74 inches of rainfall. This is moving storm data, so we don't need it. This is our depth area reduction value, and this is something more to do with moving storm stuff. R, along with the 24-hour simulation and the percent run or the percent rainfall accumulation from 0 to 1. And then these cells have the correction factor to apply the depth variable reduction for every single cell. Infiltration.dat1 means we're running green and amped. These are those global parameters from the global parameter window. And these are the parameters we saw in the in the layer right here in this table. Now, if you don't know anything about infiltration or how to set it up or whatever, I have plenty of information for you along with your county. Each of your counties have their own hydrology manuals, so you can start with them and then come to me for information. But what we have, sorry about that, I was showing you the wrong book, is this guy right here, the data input manual. And so I already have it already taken to the infill.dat file. Okay, there we go. Oh, dang it, that crashed. You know what? I'm gonna open it in Chrome because it does seem to be crashing quite a bit okay, so we have infill.dat, right? We're looking at infill.dat. So I'm gonna just go to the table of contents and click it. Should take you right to it. And you see here that you have the lines. So this is line 1, infiltration method. These are your global lines. And this is your individual line for every cell for green and amped. Of course, if you got SCS, then your SCS line is here. If you're doing Pima County or any other county that uses SCS, then you have a sample of data. And then you have a description of every single possible variable that could be in there. So your variables are laid out here so you can see what position they are, and then you can get down here and learn about the variable and what the range is and a description of the variable. And then at the very bottom, there's infiltration.dat to show you how to set up those variables and give you some extra information about setting those up. And that is done for every variable in the model, in the data input manual. So every time you do a .dat file, the way that every single variable works is defined in the data input manual, and every output file is also described in the data input manual. And there's a troubleshooting section that even has some of the troubleshooting codes you might see in QGIS in the data input manual and how to fix them. So the data input manual is kind of the gateway to Flow 2D. Okay, so we exported the data. We looked at the data, and I'm going to close that back down. And now I will run the simulation. And this time I'm just going to let it run, and we can move on to lesson 12. I'm sorry, I'm at lesson 2. Okay. Now what I'm waiting for this to start is I'm waiting for to see this screen. So now you see this is the detailed graphics. Detailed graphics slows things down, so if you don't want to use it, stick it in text mode. You don't need to see it, but I want to do it at least once just to show you what's going to happen at the end of this. So I'm going to minimize it. And the final step is, again, save and then close QGIS, and then back in here in our project folder, we will zip these two. And this take a bit longer because there's more data in there. And so if I were to mess up lesson 2 or mess up my channel, I would be able to come back in here and try it again. So I'm going to call this lesson 1 complete, or, infiltration and rainfall okay, or whatever. And you can see I should have 2 of these now. I have 2 of these now in here. And they don't take up that much space, so I'm just going to leave them alone. And that is it. So I'll pause the video now, and then we'll move on to lesson 2, which is channels.